So uh, I am Apurva Kansara. I am a computer vision researcher at Netflix. And today I was going to talk about some of the use cases for which we use Conductor at Netflix. So briefly for next 30 minutes, this is what I'm planning to share: who we are, what do we do, how do we use Conductor, and I'll walk you through one use case for which we use Conductor for AI assisted stills. So first, who we are. I think everybody knows what Netflix is, but within Netflix, we have a huge group of engineering teams that takes the content, a movie, from pitch to the launch, meaning a, a director who is filming the content, or even before that, when somebody is creating a script, from all the way to launching this on Netflix website. And our team primarily deal with the pre-production, production, and post-production part of the filmmaking, where we are assisting the artist create and promote their best content. In doing so, we utilize various different types of machine learning algorithm, including computer vision, text, and audio processing, to help them understand the best part of the best moments of their content and help them understand the best way to promote this content and assist them with that same content on the Netflix services. So there are few concrete examples that I think might help explain what we do here. One of the things that we help at Netflix is create a unique repository of all of our Netflix videos, all of the frames, all of the content that Netflix has created, to surface some key moments from that content. For example, there's a tech blog that we have published and describe the technology in details, but here are some examples where you can, for example, search within Netflix content what the red cars for a Formula One content that we created, the frames that has those red cars in there, or a beautiful moment for which we have food presented in a unique way. And so this requires us to process like all of the frames and all of the audio from our content creators that has made. One of the personal projects that I have worked on in the past is something that you might be familiar with, is the end credit identification. So whenever you're watching Netflix and when the credit starts to roll and it automatically starts the new episode of the content, there is an underlying computer vision algorithm that detects that credit sequence. And I personally created that part of the computer vision algorithm. And there are similar many other applications for which we process each and every frame and each and every audio segment within our content. Here's another example that we have published a tech blog about is, as you know, Netflix participates in an explore and exploit of our artwork. And the underlying principle is that the artwork that we present that makes you to decide a particular content might be different based on the group cohort of users. For example, an action, adventure, comedy film, right? Some people might find that the action sequences or the frames that represent wild explosions of bombs or guns might be the reason they would want to watch that movie. And there might be a comedic moment in that same movie that other people would prefer and would entice them to watch that same film. And to help our users pick the right reason to watch a particular content, we ran experiments called explore and exploit and share different types of evidence to our users to decide which content for them to watch. And part of that explore and exploit experiment that we run across all of our content, across all of our movies, we create a whole lot of artwork that our users would see at any point in time. You might have personally witnessed this when you are using Netflix, that you might see some content, a different artwork for some content, while some other account would see the different artwork. And even artwork that you see might change over time for a same movie. And the reason for that is that we are constantly learning from your preferences and understanding of what helps you pick the right content that you would most likely enjoy. Um, Now, to facilitate this sort of experimentation, we have to create so many posters or billboards and artwork for our users for any given movie. Not only the posters and billboards, but also the trailers. And the best possible way we can use our computer vision and machine learning algorithms to pick a right frame from content and then have those frames presented as an artwork to create an assisted artwork that we can bring it to our users. Here are some of the examples of stills that I have shown in this slide, which are a true uh, artwork generated on the Netflix service that is created with the assistance from our computer vision algorithms and models that our machine learning team created. There is also another part of work we do is provide creative insights. As you know, filmmaking is a very creative endeavor, and presenting film or creating trailer in itself is a form of art. Uh, and any movie visually, aesthetically, and from the storytelling point of view, you can share in a different way that appeals to different sort of people. And we have a very talented artists and creatives who use that information and their understanding of their creative insights to create the right sort of posters for the movie to promote to our users. Not just on the Netflix website, but also on the billboards that you see on LA or a bus stop or any other places. And our team helps them pick the right set of visuals or presents the right set of visuals on a similar type of content to create an artwork that affects the creative choices. So one example here is that on the left-hand side, if you see, all these posters are from different war movies, and you can see from just looking at the poster without even text, you can see that these are some kind of war type of scene. And on the right-hand side, we have kind of picked at some of the interesting way to present war, but in a different way of a profile of a person that is generated through our algorithm that our creatives decides and use that to present it to our users. There is no right answer here. Essentially, the creatives use a specific ways and their creative insights to promote a title. And not only that, depending on the user cohort, those artwork might be different. And our algorithm is uniquely positioned that it allows those creatives to make those different choices of presenting that artwork to our users. Third example of how we use our machine learning and computer vision algorithm is to create asset generation. As you know, there are many ways and many forms of content that we support, from ranging from a vertical asset that you can use for TikTok to like a whole big screen of a TV UI and a billboard. And to generate that level of artwork, it requires to change those assets based on the canvas that it has been presented. Here, one example I'm sharing is a very intelligent and automated way of cropping an asset so that it fits in a particular type of screen. But there are many other use cases for which this same image can be used across different canvases. And our computer vision algorithms are used to facilitate and build such different canvases from the same artwork. So here is the challenge. If you were to, for a company like Netflix, if you want to build an artwork from this large amount of content that we create, just to give you an example of scale, a single 1 hour movie has 86,500 different pictures. So if you look at your iPhone's library of pictures that you might have taken, you might have probably like thousands or so all together. But here, just for 1 hour of content that was shot from a camera, there's 86,000 frames. And imagine that if you look at, if you scale that to the scale of entire Netflix library, which is constantly changing and evolving, we are running computer vision algorithms to do several tasks and understanding that content such that it can be retrieved efficiently and also be used to produce and promote our art. And so this is a huge challenge of scale to process those frames at the scale that Netflix produces and promotes. And Conductor is one of the essential tasks or infrastructure tool that we use to achieve that goal. And I'll share some details on how we do that. So this diagram perhaps is not as relevant for this goal, but I just wanted to highlight that we have an array of open source technologies that we use for both internal and external tools. Some of those tools are like, as you all know, Conductor, also an open source library called Titus that we have released that essentially allows you to manage the Docker images and the containers. And this particular diagram is showing you some example of how we process the chunks of videos on a different compute instances using Conductor, Docker, and some of the underlying technologies using the internal tool called Amber. We have a tech blog that is, I will share in these slides that you can read about Amber and how we have done that. But at the heart of it, this allows us to process every single frame of every single movie in a predictable time using chunking those videos into smaller segments, but an intelligent segments of shots, and then processing each individual shots on a separate compute instance in a more efficient, time-efficient way. That we can optimize our usage of AWS compute. At the same time, we can serve the scale of Netflix. So I will go to one particular use case here that we are using that Conductor specifically. So coming back from the previous slide, if you imagine we had processed a full film of a 1 hour with 86,000 frames and found some interesting important frames that we thought that would be useful for generating, let's say, a beautiful poster for that movie, or represents the artwork in a way that you can use that poster to our Netflix websites and external places to promote that movie. So after creating that, the way we use Conductor is that we turn that single frame of that movie into what you see on the right hand side is a full-fledged horizontal artwork. That not only horizontal, but a different type of artwork that you see, like a vertical artwork on your mobile phones or all other places. As you can see, that requires us to crop in the right place, place the localized artwork and the evidence of, like, for example, there you might have seen new episode badging and Netflix logos and all sort of things with some color correction and color grading to bring that artwork to life for our Netflix product. And here is a screen capture of one of the internal tools that we use, where an artist can pick a particular frame that they think is editorially represents that particular title. And with a press of a button, they can generate an artwork that is perfectly suitable for some of the canvases that Netflix serves, without the artist doing a lot of hand holding, editing, and touching on that particular artwork. I will not be able to share the exact details of Conductor usage within Netflix environment for some privacy reasons, but I can emphasize that at Netflix, for the purpose of machine learning and computer vision, we use Conductor at a massive scale. And I will go over some of the steps we use Conductor to bring a computer vision or a machine learning algorithm to life with Conductor. I am just not able to share the specific details. Here is a screen grab of one of the Conductor pipeline that we have created that uses our machine learning model. And here is like a steps as a computer vision researcher and a machine learning practitioner. who follows in a typical Netflix environment to understand an asset or a media. So first, as any computer vision model, we would create a PyTorch or a PyTorch model with an inference that takes a media as an input and produce some form of output. In some cases, the output might be latent representation of that media that can be chained back to another models. In some cases, it might be some textual information. In some cases, it might be a media in itself that is produced. For example, if you were to have a cropping algorithm, there will be an image that it takes an input and outputs another image with a crop parameters and logo placed on that. Once we create that model and once we benchmark that model for Netflix performance, that it meets the Netflix performance, the next step is to create a Docker image that encapsulates that inference in a one singular standard Netflix container image. And that is managed by our Titus and Spinnaker. Both of these are open source frameworks that Netflix use internally, and we have open sourced it. Now, internally, we use libraries to mount media, which is to efficiently bring the IOs from the high resolution media files like EXRs from the studios that can be sent on the instance that is processing, and also write the output to conductor tasks. So as a practitioner of machine learning model, I personally don't have to repeat those work again and again. I think Viren showed in the previous example some of the packaged tasks within Conductor that they have developed at Orkes, and similarly we have created some of those tasks as well that allows us to not repeat the same work again and again. And then at the final stage, we wire it up to the Conductor workflow. With this model of development, one of the key advantage that it serves to us is we are away from managing at a Netflix level the optimization of our compute instances. For example, some of these models might require a GPU instance to process, and we want to make sure that our key business activities that requires GPU at the peak times, for example, viewing history or some recommendation services during peak hours are used for that GPU. And when the GPU is not being used during the nighttime, for example, in US, we could take that instances and use that to do the media processing pipeline tasks. So with that, and second advantage that it allows us is that single image that contains the machine learning inference with predefined inputs and output allows us to reuse that container for multiple Conductor workflows. So for example, let's say you have a face recognition, an actor recognition model that is contained in a Titus image. Then it can be used for different applications that require actors to be recognized, or let's say there is a pre-processing module that is generating, for example, a latent representation of some content that is used both for the produced media or also the pre-production stage where the things are being processed as soon as the director has shot something from the camera. In both cases, that same code can be reused across both of those pipelines without needing to share the dependencies. And this also allows us to debug, as I think the previous presentation mentioned, that debugging and understanding the failure modes of our model and able to scale, as you can see from lots of other presentations, that being able to scale for the large media processing that we do at Netflix and similar workloads with Conductor. So these are some of the reasons why we use this workflow to use Conductor as our processing mechanism. I think I've mentioned some of these advantages already. One thing is that we have language flexibility. As you can see, most of our machine learning and computer vision work is done in Python, and language of choice for a lot of our business logic is Java, Kotlin, some of those other languages. And with Conductor, we can thread all of these pieces together in a way that it is reusable and flexible for the language that the job is being done for. The business logic is separate from the AI models. So the AI models that doesn't necessarily encapsulate some of the business decisions we are making, and they continue to stay separated. As I mentioned, the large portion of work is mounting the media and reuse and IO, and we can optimize at a Netflix level with the Conductor pipelines built around it. And as I mentioned, the compute resources are the biggest advantage, that we can manage those resources at Netflix levels and reallocate based on the business needs for different types of models, because there are competing models that are trying to use the same compute resources, and that helps with that. So, and the last part I wanted to share with this group is that we use Conductor for many different parts of Netflix infrastructure. Some other places that I didn't go through details are the VFX and post-production. From the moment a director shoots a content, and even if that most of that content doesn't end up being on the Netflix service after editing, we have processing and post-processing using Conductor to accomplish those things. There are lots of VFX and post-production use cases where Conductor helps us scale geographically, as well as from scale at the level of content that we are producing, and create very timely results to our users. As I mentioned, assisted stills was one of the examples where taking a frame from a video and presenting it to the users such that people would want to watch that movie, or the reasons why they would watch that movie. Similarly, just like stills, trailers play a huge role in how people decide to watch our content, and generating clips or picking the clips that would make an amazing trailer that would help you decide to watch a content also requires a lot of processing on the content, which we use with the help of Conductor. And the last important aspect of it is, because we have such a gigantic library of Netflix owned content, there is an increasing need for us to be able to identify and locate a key moment from our content that resonates with our user. And that is called an advanced search with AI and machine learning to look for certain types of moments, also is done with the help of Conductor. So these are some of the use cases that we use Conductor with. And with that, I think I took away my time for most part. If you have any questions, I can answer that.
Apurva, thank you so much for the session. We do have a couple of questions for you. So are you able to chain and hook into different AI models in the same Conductor workflow?
Yes, we do that often, and in the some of the use cases would be when a model's output is not necessarily a human readable or a media, but rather it's a what we call latent representation that presents that information of that content that another model used to do some inference. And inference, by inference, I mean that it take that media and create some answers that are useful to our business. And for that particular use case, we would want to chain those two models together and reuse those two together such that it can produce different business answers for different use cases. The latent model might be reusable across those two.
Noted. Also, during retraining or augmenting modeling models, etc., can you keep the data that is sent to the models private? Essentially, can you host the models in-house and do all of the retraining in-house without having to send the data outside the company network?
We can, and the reason we can do is we have an internal Conductor deployment that does that, and we have our own data storage and security team that manages that data in a way that it does not go out to the public, and it continuously gets audited for. And this is a great question, by the way, and this is a very important for filmmaking. We wouldn't want a content that is not released to the public would get out. And we are able to do so because we are using our internal conductor deployment with our internal data storage such that it doesn't go out.
Thank you. Apurva, there is one question from Ketan, and he had posted this earlier while registering. So he wanted to understand what is the impact of AI in the media industry. Also, is Netflix planning to use suggestion algorithms like YouTube Shorts and Reels anytime soon?
I don't know if I'm qualified to answer this question about AI's impact on industry. I know that there is a positive value to our content creators or our media production team in how AI facilitates their work. As for the second question, I don't think I'm able to answer that.
Okay. I think that's pretty much of it. Thank you so much again for taking out time and sharing more about the work that you and your team does.